Okay, so this problem is dealing with the vectors of basically the displacement, velocity, and acceleration and their relations among each other. So radius vector. So radius vector is essentially like the point joining some reference point, some reference origin point to the particle. So radius vector of a particle varies with time t as this equation, where a is a constant vector and alpha is a positive factor. Okay. Find the velocity v and acceleration w of the particle as functions of time and the time interval delta t taken by the particle to return to the initial points. Okay, and the distance covered is during that time. Fine. So first of all, uh, r is equal to a t times 1 minus alpha t. Okay. Now one thing to notice here is this whole thing over here is a scalar, right? So what that means is basically r is always in the direction of a, either in the direction of a or opposite to a, but it is always aligned in the direction. So basically if we consider this to be o, some origin, okay, so and let's say this is the a vector, okay, then the the particle always moves in this line which passes through the origin, right? um, of course, like this is just the a vector, but since we are talking about the radius vector here of the particle, uh, and the radius vector, if it is parallel to a, it means that uh, it is some constant. So this is a scalar, of course, it is some constant multiplied by the a vector with respect to the origin o. Okay, so it is always on this particular line, right? Now, okay, so now for the first part, um, the velocity v vector is nothing but dr by dt, right? So basically similar to v being equal to ds by dt, same thing. So d, so of course we can take out the a is a constant vector, we can take that out to d by dt of t into 1 minus alpha t. Now by the product rule we know that this differentiation would become t times different d by dt of 1 minus alpha t plus 1 minus alpha t times dt by dt. dt by dt, I mean d by dt of t. So this becomes a times so this becomes minus alpha t, right? And this becomes minus alpha t. Okay. Okay. So this becomes a times 1 minus 2 alpha t. Okay. This is the v vector, and w, the acceleration is dv by dt, right? Can again take out a as common and d by dt of 1 minus 2 alpha t. So this becomes uh, minus 2 alpha times a vector. So this is w. Okay, fine. Now for the b part. Now b part, what they're saying is time interval delta t taken by the particle to return to the initial points. So basically initial point, which it means that at time t equal to 0, r vector is the 0 vector, because if we substitute 0 it will become 0. Yes, So we need to find out after what time it again comes back to r equal to 0. So just substitute. So when can r be equal to 0? Whenever this scalar t into 1 minus alpha t is equal to 0. So t equal to 0 is already a solution. So it will be 1 minus alpha t equal to 0. This means at t equal to 1 by alpha, it returns to initial position. And of course, the second part is distance s moved, covered during that time. So now this can be solved. It's a simple intuition. Now since this is all of this is along a straight line, just passing through and parallel to a vector, the trajectory of the particle, we can say that the magnitude of that, the displace, if we can call it as the displacement maybe with respect to the origin s versus t, it is along the a vector, right? Okay, so it is along the a vector. So we can say that this displacement is basically, it's the, so it is essentially the magnitude of a, right? It is the magnitude of a into t into 1 minus alpha t. This is the magnitude of the displacement. With respect to time, right? Because see, at t equal to 0, it is at origin, right? So after t equal to 0, it basically starts from the origin itself, right? So whatever is the so this is basically the displacement from t equal to 0, we can say, right? Because it's starting at the origin. Okay, now this thing, this is of course a constant a, this thing t into 1 minus alpha t, so it's basically a quadratic equation. I shouldn't shouldn't tell it as a quadratic equation. It's a quadratic expression rather, whose roots are 0 and 1 by alpha. Yeah, right? So 0 and t equal to 0 and t equal to 1 by alpha. Basically, it comes back, it is at the origin. And so if you see t into 1 minus alpha t, at any given point between 0 and 1 by alpha. So okay, let's see it this way. So for any so it is basic, the equation, the curve will be a parabola. So for a parabola, whenever you have the double differentiation is over here, as you can see, it's negative, right? Alpha is positive, so double differentiation is negative. So once let's check, alpha is a positive factor, right? So since the double differentiation is negative, it's a parabola that faces downwards. Okay, so basically the curve would be something like this, right? Okay, so and it will be symmetric across the midpoint of these two. So it will be symmetric across 1 by 2 alpha. Basically at 1 by 2 alpha, so you can also see that at 1 by 2 alpha the velocity should be 0, which it is. If you substitute 1 by 2 alpha over here, then yeah, the velocity becomes 0. So basically it keeps moving towards it keeps moving in one direction. Basically at 1 by 2 alpha the velocity becomes 0 and then it reverses its direction. So you can also see from the slope, this curve initially positive, then at 1 by 2 alpha it becomes 0, then it starts becoming negative and the magnitude keeps on increasing till at 1 by alpha it is at the origin. So now what we have to find out is basically the distance covered. So distance covered will be what? Distance covered would be, so till 1 by 2 alpha, basically it covers some, it has covered some s max, let's say, and it returns back. So it is like you are here and the particle is here at t equal to 0. It goes to some point B where this is s max, right? And it again comes, it goes there and it again comes back at, this is at t equal to 1 by 2 alpha. It changes its direction. T equal to 1 by alpha, it again comes back to A, which is the origin over here. I should replace it by O rather. O. Now, okay, so basically we need to find out 2 into S max, which is the distance covered. What is S max? If we substitute 1 by 2 alpha in the displacement equation, which is this, we'll get that. So, okay, now this becomes 2 times mod A, T is 1 by 2 alpha into 1 minus alpha into 1 by 2 alpha, right? So alpha cancels out, okay? 2 cancels out. Oh, I'm so sorry. 2, not that 2. 2 and this 2 cancels out, yes, okay. So this becomes A, magnitude of the A vector, divided by, this 1 minus half is again half, so 2 alpha. So this is your distance covered in that time. So there you go. So basically that is how this question is solved. Thank you.